Okay, part 2 of 1.3, properties of real numbers notes. Remember yesterday we went over all those properties of our additive properties, our multiplicative properties, and then we had some inverses and some identities in there. If we multiply a number times 1, we get that number back. If we multiply a number by 0, we get 0. If we add 0 to a number, we get the number back. If we add a number and its opposite, we get 0. If we multiply a number by its reciprocal, we get 1. You guys remember those properties from yesterday a little bit, hopefully. Okay. So let's continue with this lesson. Today we're going to talk about the commutative and associative properties. An easy way to find the sum or product of numbers is to group or associate, that's why it's called the associative property, the numbers using the associative property. For the addition and multiplication of real numbers, the order does not change their sum or product. This is called the commutative property. Essentially, for sum and product, the commutative property, 3 plus 4 is the same thing as 4 plus 3, right? It does not matter what order I put it in. 2 times 3 is the same thing as 3 times 2. Same thing for multiplication. We good with that? Okay. So, here are the associative and commutative properties just written out like all of our properties were yesterday. Associative property, the way you group 3 or more numbers when adding or multiplying does not change their sum or product. So, for any numbers A, B, and C, if I have A plus B plus C, I can group A and B together, add those first, and then add C to it. Or I can group B and C together, add those first, and then add A to it. It does not matter which numbers I associate together first. Same thing with multiplication. I can do A times B first, and then I'll multiply by C. Or I can multiply B and C together first, and then multiply A to it. Okay? And here's some examples with actual numbers, if you guys like to look at it that way. Questions on the associative property? Okay, commutative property. The order in which you add or multiply numbers does not change their sum or product. So like I was saying earlier, here's some other examples. 8 plus 12 is the same thing as 12 plus 8. It does not matter which number I have come first. Same thing with multiplication. 4 times 9 is the same thing as 9 times 4. It does not matter what order I have those numbers in. Is there any questions on the associative property or the commutative property here? Okay, I'll give you a little time on this slide. So let's go ahead and move on for time's sake. Example 7 here. Jalen wants to add up how much money he spent on gasoline in July. He grabs the 4 receipts he has for July and writes the expression that represents the total amount he spent. Evaluate the expression to determine how much money Jalen spent on gasoline in July. So, here's his 4 receipts from his gas fill-ups on his car. He wants to find the total amount he spent in July. So how would I find that total amount given these 4 receipts? Add them all up, right? That's going to give me the total amount of money he spent on gasoline in the month of July. So, what's the first amount? $34.50. We said we're adding, so plus $32.50 plus $23.25. I'm going to move that over. Plus what? $31.75. Okay. If this was just a normal, well, it is a normal problem, but up to this point in our mathematical careers, we'd probably just do the order of operations and work left to right. Add this, whatever we get for that sum. Add this to it, whatever we get for that sum. Add this to it. Correct? That's probably what you would do. But we have these special properties now. This problem, we're specifically going to use our associative property. I can group numbers together if I'm adding or multiplying. This is all addition, isn't it? So to kind of speed up my addition process, I can group some of my numbers together and kind of lump multiple steps into one step, if that makes sense. So instead of just adding here, and then adding here, and then adding here, I can add these two numbers and add these two numbers in the same step. That'll give me two numbers, add those up. So it's essentially eliminating one step for me. Okay? So, what's 3450 plus 3250? What's that going to give me?
67.
What did we say?
67.
67. I've got this plus sign here that I'm bringing down. 2325 plus 3175. What is that going to give me? 55. Even. If you want to put the 0.00, you can. But we don't have to. Does everyone see how that's kind of sped up my process a little bit? I've kind of combined two steps into one step by using my associative property, by associating two different groups of numbers together. Okay? Now I'm just left with two numbers. I can just add these up to get my final answer. What's 67 plus 55? 122. So in the month of July, Jalen spent $122 on gasoline. That's pretty cheap, actually. Are there any questions on example 7 and how we used our associative property to group numbers together? We good with that? Can I move on? Okay. Another example, example 8. Evaluate 5 over 6 times 9 times 6 over 5. 5/6 times 9 times 6/5. Any ideas what to do here?
Can we do 5 over 6 times 6 over 5?
What property would we be using when we do that? Do you remember?
Multiplication inverse.
Well, those are multiplicative inverses of each other. But today, if we change the order of our product, what would we call that? What property? Our commutative property. This is all multiplication, correct?
Yes, sir.
So the commutative property tells me the order in which I add or multiply numbers does not change their sum or product. So I can multiply the numbers in any order I want. I don't have to do 5 over 6 times 9. That's going to give me some nasty fraction. Whereas we know that 5 over 6 and 6 over 5 are what of each other? They're the multiplicative inverses, or what was that R word we used? Reciprocals, right? What happens when I multiply a number by its reciprocal? Not 0. 1, right? Anytime I multiply a number by its reciprocal, by its multiplicative inverse, I get 1. So does everyone see how changing the order here has made my life a lot easier?
Yes, sir.
Because if I did 5 over 6 times 9, that would give me 45 over 6 times 6 over 5. Which doesn't look very fun, does it? Whereas I know, hey, these are reciprocals of each other. So I can change the order here. If I multiply a number by its reciprocal, I get 1. And that looks a lot easier here than this right here. Correct? So does everyone see how this made it much easier for us?
Yes, sir.
I'd much rather deal with 1 times 9 than 45 over 6 times 6 over 5. Right? So what is 1 times 9? 9. Which, by the way, 1 times 9 is another one of our identities. That's our multiplicative identity, right? Anytime I multiply a number by 1, I get that number, right? That's one of our properties from yesterday. Any questions on example 8? We okay there? Okay. It's my last example, then I'm done. Told you it was faster than yesterday. Jade buys groceries once each week, and she wants to calculate how much she spent on groceries over a 4-week period. Evaluate the expression to find how much Jade spent at the grocery store. So, she shops weekly. Here's her 4 trips totals to the grocery store. She wants to calculate how much she spent over a 4-week period, so pretty much for that month, right? So if I'm wanting to find the total, what would I do here? Add them together, right? So 32 plus 27 plus 28 plus 33. Right? Here, we're going to use we're actually going to use our associative and our commutative here. Okay? Commutative tells me once again it does not matter the order in which I add or multiply numbers. Right? Does anyone see 2 numbers that would be easier to add together than any other 2? Give me a nicer number, kind of.
$27
27 and 33. That's going to give me a number that ends in 0, right? Also, what about 32 and 28? That's also going to give me a number that ends in 0. So, the commutative property tells me that I can change the order of my addition problem to make it a little easier on myself, right? So, I'm going to go ahead and erase this. I'm going to do 32 plus 28 plus 27 plus 33. So there's my commutative property. I change the order in which I'm adding the numbers, right? What does the associative property tell me I can do?
You can group them.
Yeah, I can group numbers together to kind of shorten my process, right? So here, I'm going to group my first 2 numbers together, my last 2 numbers together. I can now do both of these addition problems within the same step. So, 32 plus 28 gives me what? 60. 27 plus 33 gives me what? 60. Now I've got 2 really nice numbers. They both end in 0. And I'm just adding them. It's going to be a lot easier than the other numbers I would have gotten if I didn't change the order up. What's 60 plus 60? 120. So Jade spent $120 on groceries within a 4-week period, which is really, really, really cheap. I want to shop where she's shopping. Any questions on example 9? Does everyone see how the commutative property helped us move the numbers around to get easier numbers to add together? And then we use the associative property to group those numbers together. Any questions on that? Okay. Once again, I have created an online assignment for you. How do you guys feel about those online assignments?
Terrible.
Terrible. Okay.
Oh. No, they're actually so long.
So you'll be looking for 1.3, homework number 2, MH. That's what you're going to be looking for on Canvas under today's date, under the module for this week. Are there any questions about my notes before I end the recording?